Okay, everybody take a look at this. This is a really cool problem we can do. This seems kind of non-mathematical, but many things do that can be proved mathematically. It's amazing how much stuff you can do with math. In fact, it's amazing. There's a topic for some time. It's amazing. We probably talked about this a couple of years ago, but we could go further. It's amazing and kind of odd that math does as much stuff as it does, that it can be used essentially in every situation to model stuff. That's a little weird in our universe, but it seems to be that way. So is our universe a mathematical structure, in fact? Okay, but I digress. Let's get back on track here for a second. Okay, so at 8 a.m. on Saturday morning, a man begins running up the side of a mountain to his weekend campsite. There he goes, up to the top, okay? Sunday morning at 8 a.m., he runs back down the mountain. It takes him 20 minutes to run up, but only 10 minutes to run down. At some point on the way down, he realizes that he passed the same place at exactly the same time on Saturday. Prove that he is correct. I double dog dare you. How could we do this? That's right. Yeah. IVT, you got to use IVT, don't you? Now, so let's think about what are the two criteria for IVT, because we don't have to. It doesn't ask when it happened or anything like that, right? It just wants us to verify that it did happen. So we could hopefully, and you're on the right track. Could you use IVT to prove that a solution exists in some context that could apply here? Okay, so what are the two criteria for IVT? See if you can do it without looking first. See if you can. Say it again. Okay, in fact, it's got to be a little bit even more. Okay, true, it has to be defined. But on our interval, some function has to be not just defined, but what? Has to be continuous on the closed interval, right? Okay, on some closed interval. Okay, that's one. What's the other one? Okay, there has to be some intermediate value, right? So there has to be a value that is between the value of the function at its endpoints, okay? And if those two things are true, then the function is guaranteed to take that immediate value on the open interval between the endpoints, right? So then in a situation like this, I want to make this, I'm going to give you a couple little hints here so we can move this along so you guys can use the time too. We have to come up with some function, right? The function, what's going to be the input on our function probably? The independent variable. Instead of an x, in this case, it's probably a what? Previously, we'd looked at situations where we showed that there had to be some x value where the function passed through an intermediate y value, right? Okay, this time it's probably not going to be x. What's it going to be? What's our input going to be? Time, probably, I heard it, probably time, right? Wouldn't that make sense? And what's the function going to be? I mean, like, what are we dealing with here? What kind of a function do you suppose we're talking about? Something as a function of time. Well, now he notices, this is crucial. He notices that he passed the same place at exactly the same time. Well, place on his hike probably corresponds to what? How would you know what place it was? I mean, what's that mean, the same place? That might mean he passed by. Say it again. Same point. Okay, but like what kind of a, you're right, same point, but what kind of a quantity might we be measuring there? Okay, position maybe, right? Like position, or in this, does that make sense? His position on the trail, right? That would be the output is position. So time, position as a function of time, right? Okay. Okay. Okay, does that make sense? So position relative to, say, the trailhead, right, where he starts. Agreed? Okay. So, hmm, how could we set up some function then where we would meet those criteria? Let's just see if this makes sense. How about? So if S and T and R of T are the positions for the runs up and the runs down, let's just say S of T corresponds to up and R of T corresponds to down, the position functions. Okay. How far did he travel? Did it tell us? Never tells us. That's all right. Doesn't matter. Like it's whatever the total distance is. That's, it could be a mile, could be 8 miles, who knows? But it's not 8 miles if he's doing it in 10 minutes, right? It must be pretty short. He's coming down in 10 minutes. But how could we set that up then? Well, how about this? What if we let f of t equal his position on the way up minus his position on the way down? Or would we want to flip that? Doesn't matter. Really doesn't matter. When we get into it, we can see if we'd rather rearrange that. Okay, so let's talk about on Saturday. What is on Saturday? What is, oh, never mind. This is on, right, so this is the way up. So this is Saturday, and this is Sunday, right? Okay, so what is the value of the function at 8 a.m.? What is his position? We said S is his position on Saturday. What is his position at 8 a.m. on Saturday? 0, right? He is at the trailhead. His distance from the trailhead is 0. Agreed? Okay, so 0 minus, what is his position on Sunday at 8 a.m.? At the top, whatever that is. Let's call this distance, we'll just call it D, the distance to the top. Okay, so it's 0 minus D equals negative D. Okay, how about at 8:20? Because at 8:20, he's either on Saturday, he's all the way up to his camp. On Sunday, he's back down to the trailhead, and he's been sitting there for 10 minutes, right? So what is f of 8:20 equal to? On Saturday, his position is D. On Sunday, his position is 0. Aha, so it's D. Went off the board there, right? That's supposed to be equal to negative D, and this one is equal to positive D. Is this function f of t continuous? Has to be, right? Because isn't s of t continuous? Right? His position function on Saturday is continuous. He's not teleporting from one place to another, right? In an instant. He has to travel through all the points from the trailhead to the destination on both days. So because each of these are continuous functions, the sum of those two, or the difference of those two, has to be continuous also. So we met that criterion, right? The function is continuous. Did we meet criterion 2? Well, let's see. F of 8 equals negative D, and f of 820 equals positive D. When he passes the same point at the same time, what's going to be the value of F? So when this happens, the underlined part, oh my goodness, I can never hit those. So what does that correspond to? F of whatever that time is, we'll call that the time when he hit the same place. What would the value of F be there? Got to be 0, right? Because the positions are the same on Saturday and Sunday. That's what it means to pass the same place at the same time, right? So there's going to be some time when his distance from the trailhead on Saturday is the same as it is on Sunday. Agreed? Right? Okay, well then we met all the criteria, didn't we? The function f is, and what are these? F is continuous on 8, the closed interval from 8 to 8:20, right? F of whatever we're calling that, F of t sub same, whatever that time is when he's at the same place at the same time, equals 0. So that is F of that time is less than F of 8:20 and greater than F of 8. So we can check off both criteria. What does that guarantee then? What did we just prove? It has to happen, doesn't it? Right? That there has to actually be some place on our interval where the value of f is 0, right? That's what would f of some time equals 0 when he passes the same place at the same time. We don't know where that is. We'd have to do some more additional math to actually find that place. But we just guaranteed that because 0 is between the values of our function f at the endpoints at 8 and 8:20, and our function is continuous on that interval, that place has to exist mathematically. It's 100% guaranteed. So you do, in fact, pass the same place at the same time. Have to. Okay? Everybody see that? That's pretty cool that you can prove that. Intuitively, you might be able to convince yourself that it has to be that way, but that's not a proof, right? A proof is irrefutable evidence that it does happen, and there it is. Okay? Make sense? All right. I am done. Anything you absolutely have to briefly discuss, or are you guys good to go on just working?